Good day. So in today's video, it would be the chapter 8. The topic would be open channel. So once you have heard about open channel, so it is always called as partially full conduits, no? Accordingly, sa book, there are two types of conduit used to convey water. The first one would be the open channel, no, yung two types to convey water. H2, open channel, and the other one would be pressure conduit, or simply the pipe. An open channel is one in which the stream is not completely enclosed by solid boundaries and therefore has a free surface subjected to atmospheric pressure. The flow in such a channel is caused not by some external head, but rather by the gravity component along the slope of the channel. In open flow or open channel flow, no, the hydraulic grade line or HGL is coincident with the stream surface since the pressure at the surface is atmospheric. The flow in an open channels may either be uniform or non-uniform. Always remember with that. So for example, no, this is the illustration of what I have read. For example, this is the channel bed. So it is inclined. And this is the HGL. Medyo inclined siya. And this one is the EGL. Or simply the slope. So sorry for my drawing now. And so this one here, dito, section 1, section 2. From the datum here, it would be S sub OL, the D1, V squared over 2G, the head loss here, SL, EGE, which is V squared, V sub 2 squared over 2G, and this one is D sub 2. So specific energy. The specific energy, or simply symboled as H, is defined as the energy per unit relative to the bottom of the channel. It is given by H equals to V squared over 2G plus D. No? Yung H, V squared, ito, H to. Or is specific energy. So with that, we will be using Chazy or Chazy formula. The head loss between any two points in the channel is HL. Ito, head loss, which is SL. Yung S is the slope of the energy grade line, which is itong EGL. Slope, ang L naman is the length or the run, no? Head loss is yung slope at saka yung length, SL. Ito yung formula. The head loss balances the loss in height of the channel. So from Darcy-Weisbach relation, no? Okay, Darcy-Weisbach. Which is H sub L equals to FL over D V squared over 2G. Remember that, no, where D equals to 4R. So therefore, the formula would be H sub L equals to FL over 4R times V over V squared over 2G. Right? So we can times 4 and 8 and 2. It would be 8. And then the L would be cross multiplied. So it would be H sub L over L equals now to F over 8R times V squared over R. And always remember that from here, no, Chasey formula, which is H sub L over L is S. So ito na yun. Slope equals now to F over 8R times V squared over R. So in terms of velocity, so ito, targetin natin to, so V squared equals now to 8G over F times RS, no? So it would be square root both sides. So V equals now to 8G over F, which is, this one is raised to 1/2. Remember that square root is equals to or raised to 1/2, and times RS raised to the 1/2, no? So this is now the formula in terms of Darcy-Weisbach, no? Kapag may F, yung friction factor, so it would be Darcy-Weisbach. What if for a given channel slope and bottom roughness, the quantity is 8G over F raised to the power of 1/2 is constant and can be denoted by C. So this one can be denoted by C. So it would become, no, V equals to C times RS. Yung RS is raised to the 1/2. Ang C is Chasey coefficient. Or we can write as V equals to C times square root of RS. And remember that from Q equals to AV, right? Discharge equals to area times velocity. So therefore, we can have this Q equals now to area. Value ng V is C square root of RS, right? Or A equals to 8G over F raised to 1/2 times square root ng RS. So this two. So that would be about Darcy-Weisbach and Chasey formula, no? And now another formula to be introduced is Cotter or Cotter and Gangulet. So formula. So this formula would be given, no? It would be NSI. It is 1 over N plus 23 plus 0.00155 over S, which is all over 1 plus N over the square root of R times 23 plus 0.00155 over S. So, now proceed to another formula, the Manning formula. Manning formula, which is C equals now to 1 over n times r to the power of 1 over 6, where V equals to 1 over n times r to the power of 2 over 3 times s to the power of 1 half, and this charge equals now to AV, wherein A times 1 over n times r to the power of 2/3 times s to the power of 1 half. No, this 3 is in SI. And now next formula would be Basin formula or Basin. It would be C equals now to 87 all over 1 plus m over the square root of r. Again, it would be SI. So always remember na n is the roughness coefficient, m is Basin or Basin coefficient, r, which is equals to A over P, which is this one is weighted per meter. R is hydraulic radius. S is the slope of energy. Energy grade line or GL or EGL. EGL. Now let's proceed to uniform flow, which is yung slope is equals now to the slope sub O or origin. S sub O which is is that slope sa channel bed, no? Yung S is sa grade line, yung S sub O is sa channel bed. So uniform flow, which is S, again slope ng EGL equals now to sa slope sa channel bed. For the flow to be uniform, the velocity, depth of flow, and the cross-sectional area of the flow at any point of the stream must be constant, which is, or that's why V sub 1 equals not to V sub 2, D sub 1 equals not to D sub 2, A sub 1 equals not to A sub 2. For this condition, the stream surface is parallel to the channel bed and the energy grade line. Yung kanina, so there is no incline na. Tupong na tanan is parallel to the stream ng surface, and therefore the slope of the energy grade line, which is itong S and S sub O, is equal, no? Yung slope of the channel bed. Again, specific gravity, no? So, okay na to. Next is the boundary. Stress. Or yung tau sub O. The average boundary shear stress acting over the weighted surface of the channel is given by ito. Tau sub O equals now to gamma RS, no? Wherein the unit weight of the liquid, ito, unit weight, R is the hydraulic radius, so kinatay nito, S is the slope of the energy grade line. Again, slope siya ng EGL. So, normal depth. Bakit ganito yung penmanship ko? The normal depth, or D sub n, is a depth at which uniform flow will occur in an open channel. Normal depth may be determined by Trapezoidal formula with Trapezoidal formula S equals to S sub O. That's why. So that you can understand more about this formulas na gihatag or I have given. So let's have this example. First example. So this would be the first problem that I have shown you for chapter 8. So the problem is water flows uniformly in a rectangular concrete open channel that is 8 meters wide at a depth of 2.5 meters. The channel slope is 0.002 using n is roughness coefficient 0.012. Find the velocity, flow rate, and the boundary shear stress. So tatlo. So first things first, we should have illustrated as per instructed sa problem. So for example, or take this as assumption na ganito daw yung open channel. So for you to acquainted sa problem like mga open channel, so i-search nyo ano yung itsura ng open channel. So hindi lahat ng mga channel or conduit is in circular. Again and again, it can be differed, So 2.52 meters kasi sabi dito depth, Tapos dito is 8 meters. And mayroong slope na 0.002. Again, equal din siya sa channel. Slope ng channel bed. So, hanapin natin yung velocity. Sa velocity, as we can observe naman, for example, puno to. So, the only thing na we can think of is that meron siyang S. And we can solve the area of it as well as the parameter. So, stick tayo nito. V equals now to 1 over n. May roughness siya. So, gagamitin natin yung formula ni Manning formula. Kapag may n, kay Manning yan. Kasi roughness coefficient, R to the power of 2/3 times S to the power of 1/2. Wherein ang R is A over P. And, what is the area? So, 8 times 2.5. Length times the depth, Yung perimeter is ito lang, isa lang to, ang dalawa dito. So it would be look like closed na, pero open talaga yan. So 8, ito perimeter, tapos dalawa na deep. So 2 times 2.25. Therefore, our hydraulic radius is 1.538 meters or meter. So, input natin yon. V equals now to 1 over n. Ang n is 0.012 times the R would be 1.538 times the S, which is 0.002 raised to 1/2. Ito naman 2/3, o yung R. So, our velocity now is 4.966 meter per second. So, B, which is the flow rate, the Q. So, related again to Manning. So, Q is AV, right? And V, as we have encountered earlier. So, A times 1 over N r to the power of 2/3 s to the power of 1/2. So given na ito is ito, so area is 8 times 2.5 times 4.966, right? So our flow rate now is 99.32 cubic meter per second. So, okay. C, yung boundary stress, shear stress, which is I have introduced to you, no? Yung tau sub O. So, tau sub O equals now to unit weight times RS. Ang unit weight natin is waterman. So, therefore, 9.21 lang times, suot sa natin yung formula. Unit weight RS. R is, ano yung R? Hydraulic radius is 1.538 times S, 0.002. So, the answer would, the boundary is 0.0302 kilopascal, no? So, convert natin to Pascal. So, 1 kilo times 1,000. Cancel. So, our answer would be 1, 2, 3. So, 30.2 Pascal. So, second problem or example. So, the second example would be a trapezoidal channel has a bottom width of 6 meters and has side slope of 2 horizontal and 1 vertical. If the depth of flow is 1.5 meters or meter and the flow is 21.50 cubic meters per second. So, we are asked to compute first the specific energy. Next, slope of the channel if the roughness coefficient is 0.012 or 13. Average shearing stress at the boundary. Solution ito, no? Solution. So, again and again, use ruler for nice illustration. So, let's think of ito yung sign here, here. Or so ganito for example, no? So as you can see, ganyan ko siya. Parang may nakaset na point kung saan yung sa bottom. So this is now the channel, trapezoidal na channel. So accordingly, yung depth daw ng normal depth, no? Or yung flow ng depth or depth of flow is 1.5 meters. Tapos yung dito, which is just an illustration naman, so it would be much longer pa. So A equals now to 6 meters. I'm thinking that sinabi dito, yung vertical is 1 at yung horizontal is 2. So yan yung slope na sinasabi. And let's think of it, of this, from here sa flow or depth of flow to the bottom is y, no? And this one, this one, this one, this one, let's assume it as x ito 6. Tapos, ito base, no? Bibig niya. Or, para hindi kayo malito, dito tayo sa, no? Mag-base sa tip of flow niya. Which is, dito naman talaga. So, wala to. So, yung B is 2x plus 6, right? Ito ba? B man to. A dito, B dito. So, B, A. So, as you can observe, we can use the triangular, no? Or similar triangle. Diba, ganyan. Tapos, 1.5 to. Ito naman si x, no? X. Right? Tapos si ganyan naman 2, 1. So, x over 1.5 equals to, horizontal and horizontal, so 2 over 1. So, ganyang, this would be similar triangle. So, therefore, the x is 1.5 times 2 equals multiplied into, so 3 meters. And our B now is 2 times x, which is 3 plus 6. So, 12 meters yung B. So, yung area natin, and as we know, area ng trapezoid is 1/2 times yung upper and lower, no? Nalan times yung deep, which is 1.5. So, it turns out na 1/2 times 6 plus 12 times 1.5, wherein it would be 13.5 square meter, no? Area. Ito ba? Area nito. So, yung weighted perimeter, yung P, so, the goal here is to, of course, yung radius, no? Or hydraulic radius, which is A over P. So, we need to find sa P. Ito, again, is the wetted perimeter. Wetted perimeter. Which is, as you can observe, di ba ito Y? Y din to. And plus yung A. So, 2y plus A, which is 2, ano naman yung Y, plus 6. So, we need to find the Y. Diba? Ito yung Y, and 1.5. Ito Y. Ito si X, which is 3. So, the very close na we can use is the Pythagorean Theorem, PT. Wherein, diba, A squared equals to B squared plus C squared. Let's say na si A squared, or si A is the Y squared, si B would be X squared plus 1.5 squared. So, Y equals the square root of, yung X is 3 squared plus 1.5 squared. Therefore, the Y is 3.354. So, go back here. So, P now is 2 times 3.354 plus 6, which is 12.71 meters. So, our hydraulic radius is A over P, or 13.5 over 12.71, which is 1.06 meter. Diba, we are asked sa specific energy. And specific energy is yung H equals to V squared over 2G plus T. Yung depth natin, or depth of flow, is 1.5. So, we are very near na sa Actually, we can get naman sa specific energy, no, without the use of R, because it only needs the velocity, no. So ito pang reserva lang to for other, no, questions. So, 'di ba, as we have known na Q equals to AV, which is now V equals to Q over A. Given yung flow, which is discharge, which is 21.50 over yung area, which is 30.5. So, yung V natin is 1.59 meter per second. So, therefore, our A is H equals to V squared over 2G plus D, or 1.59 squared over 2 times 9.81 plus 1.5. So, our specific energy now is 1.63 meter. Sa B, yung slope. So, as we have known, di ba, V, through the use of Basin Formula, since given na yung N, or roughness coefficient sa B. So, it would be, dito ba? Meron man. Diba, from here, so connected lang yung mga answers dapat natin. 1 over n r to the power of 2/3 times s to the power of 1/2. So, we are very interested with this s. Since given ng, let's do the math, no? Or simplify so that napa natin to. So, s to the power of 1/2 is v over 1 over n times r to the power of 2/3. So, squared both sides. Para matanggal si 1/2, s now is ito. Which is, diba yung n is pwedeng man-numerator. So, vn over r to the 2/3. Pero, naka-raise to ng squared. So, solving it, V is 1.59 times N is 0.013 over 1.06, diba yung R, to the power of 2/3. So, raise ng 2. Therefore, our S, or slope, ito, slope of channel, it would be 0.00395, or simply, approximately to 0.004. This is the answer. C. Itong average shearing stress at the boundary, or boundary shear stress. So, we can use the tau, no, which is unit with RS, which is 9.81. Yung R is 1.06 times 0. Gamitin natin to, 0.004. So, yung boundary natin shear stress is 0.00416 kilopascal. Again, times 1 kilo 1,000. So, it would be 1, 2, 3. So, 4.16 Pascal. So, this is the answer. So, next topic would be most efficient cross-sections. So, it is also called as the most economical. Sections, which for a given slope S, channel cross-section area A, and the roughness coefficient N, the rate of discharge is a maximum. So, naka-maximum lahat, no? Let us suppose that you are required to design a rectangular canal to have a cross-sectional area of 8 square meter. The possible dimensions, no? If given na meron tayong ito ang real life situation na square meter na rectangular lang daw. So it would be like yung base is 8 meters at yung deep, no, yung deep would be 1 meter. So 8 times 1 is 8. No. 8 times natin siya. So ito times, no? 8. Next option would be yung base is 2 meters tapos yung deep is 4 meters. Next option, di ba? 2 times 4 is 8. Yung base is 1 tapos yung deep is 8 meters. So 1 times 8 is 8. Fourth option would be base is 4 meters tapos yung deep is 2 meters, which is 4 times 2 is 8. So what is the most economical one na dimension na gamitin natin? So let's say yung perimeter, solving the perimeter, no? Thinking that this deep is times 2. So 8 plus 2D. No, 8 plus 2 times 1, it would be 10 here. And next is 2 plus 2 plus 2 times 4, it would be 10 again. Next is 1 plus 2 times 8 is 16 plus 1, so 17 meters. And lastly, 4 times 2 times 2, it would be 8 meters. So, as you can see, this is the most economical section na with this, no, 8 square meter. So, of these dimensions, it can be seen that the size 4 meters by 2 meters has less weighted perimeter. So, siya yung pinakamaliit or having the less weighted perimeters. Hence, it is the most efficient or most economical section. So, yung proportions for most efficient sections, efficient. So, first, sa rectangular, which is thinking again na ganyan, no, rectangular. So this one is 2D at tapos 2 to. So area now is BD. So 2D times D, it would be 2D squared. At yung radius, A over P, which is 2D squared over dalawa times 2D. So 4D squared, or simply hindi. Kasi 2D to, 2D. So 4D lang. So cancel D to 1/2. So D over 2 yung R. No? Next one would be the triangular section. The most efficient section when the vertex is 90, no? So for example, ganyan. So perpendicular daw to. D. For example, perfecto na. Sorry for my drawing, no? So, to dito as a whole. Ito, perpendicularity, no? Angle perpendicular is 90. Ito, yung side niya is C. Therefore, the area is 1/2 BH. And 1/2 BH, yung B is 2D. Yung base, 2D. Tapos yung height is D. So, therefore, cancel to 1/2. So, D squared kapag triangular. At yung hydraulic radius is A over P. So, D squared over at perimeter, no? Ito. So, it would be like 2 times square root of 2D. 2D squared. So, D squared over, palabas natin to 2 square root of 2D. So, cancel. So, our R is D over 2 square root of 2. Next one is yung trapezoidal section. So again, this one. So this is the A, which is, let's say, same to. So B to. Do anything B to B. And let's say, kasi we're proving this na efficient siya. So, ito yung tip. Diba? If this is 90, so this one is, ano, 30. So, we're forming here 120. No? Kaya nasabi kong 30 to, kasi this would be 90 here, 60 here, 30. No? So, using that, no, assumption na 30 to, and dito B, ito is D. And here, let's say it is X. So, opposite siya, tapos hypotenuse. That is our target. So, kaya sine X over D. And our X is cross multiply, so B sine 30. Which is, it would be 0.5B. No? So, we can assume na itong X is 0.5B. Or kalahati ng ating B. So, therefore, the area here is that 1/2 times A plus B times D, which is 1/2 times, ito, total nito is 2B. Diba? B na to, 0.5. So, B times, dalawang B na, so 2B. So, B plus 2B times D. And we should find our D. Diba? ito D, ito 0.5, ito B, ito 30. Or we can use naman the PT. So, D equals the square root of B squared minus na no? Kasi supposed to be ito yung A squared. Pero ito man, so lipat natin. So 0.5 squared or 0.5B squared. So our D now is square root of B squared minus 0.25 B squared. So pwede natin itong i-minus, which is square root of 0.75 B squared. So our D now is 0.866 B. No? So our A, or area ng ating trapezoidal section, it would be 1/2 times B plus 2B times so let's do tama no? 0.866 B. So therefore it would be 3B no B 3B na plus ito, it would be 4.433B. So our A now is 1.3 B squared. Mali. Mali yung operation. Dapat times 2. So 1.3B. And our we know na B, tatlong B naman. So 3B yung weighted area. So R now is A over P, which is 1.3B squared over 3B. Cancel, cancel. So our R is 0.433B. So sa circular naman tayo. Section. A circular channel will have its maximum discharge when the depth of flow is D is 93.8%. So D niya dapat 93.8% daw of the diameter of the D. And the velocity is the maximum when the depth is, so yung V is 82% daw ng diameter. So therefore, if let's say na let's draw a circular, no? So ito circular section. Ito like ganyan. Which is naka-Qmax na daw siya. And let's say 98 man daw yung discharge, I mean yung diameter. Ganyan. Diba sabi naman discharge, then so yung D natin is 93. So 3.8% of diameter, or simply 0.938 tapos D, while yung velocity is 0.82 D, no, 82%. The most efficient cross-section of circular section is the semicircular, no? Kung semicircular lang. So let's use the formulas I have introduced to you to examples, mga problems, no? Example number 1 here. So the problem is, or the example for the most efficient proportion or cross-section or mass it would be a triangular channel with most efficient proportions, discharging water at the rate of 1 cubic meter per second. Assuming that the roughness coefficient is 0.014 and the slope is 0.0021, calculate the normal depth of flow. So the solution would be the triangular section, the most efficient proportions when the theta is 90. Right? So we need to find the normal depth, or the D. This one. So to be able to find it, so we need to use the formula, no, na considering yung mga given. So it would be Q equals to AV, wherein A times 1 over N times R2 2/3 S 2 1/2. So yung area natin based sa triangular, no, ito it is d squared, yung hydraulic radius is T over 2 square root of 2, and the discharge is given, so 1, diba, 1 cubic meter over second. So yung A is area is d squared, at yung R is D over 2 square root of 2, which is raised to 2/3, at yung S is 0.0021 to the power of 1/2. No? If we do the math here, like ito, yung value para ng 1 over n. So dito 1 over 0.014 times natin to. So 1 times 0.0114 times d squared, which is times natin sa d to the power of 2/3 over 2 square root of 2 2/3, tapos itong slope is 0.045 8, no? So it turns out na this one is 3 times 2 is 6 plus 2 is 8. So 8 over this one would be d to the power of 8 over 3. So d 8 over 3 is now equals to 1.0014. Ito times 2, ha, times tong 2 square root of 2 2/3 over 0.0458. So 3 over 8, erase natin to both sides, 3 over 8 para cancel. So our depth is 0.83 of a meter, no? This is the answer. So second example. So the second problem is an open channel is to be designed to carry 1.5 cubic meter per second at a slope of 0.007. The channel material has an N value of 0.012. Find the most efficient cross-section for semicircular section and the rectangular section. So as you have noticed, so meron siyang roughness coefficient. So we will be using the Manning's formula, no? Find the most efficient cross-section. First, a semicircular and rectangular. So first, so let's draw a semicircular. Semicircular lang daw. Yan. So thinking that this is diameter and this one is the radius, no? So our Q is area times B, wherein A times 1 over N R to the power of 2/3 times S to the power of 1/2. Our area here is pi r squared over 2 kasi semicircular, no? Our perimeter is, diba, 2 pi r. Yung circumference divide 2, so pi r na lang. At yung r natin is pi r squared over 2 over pi r. Cancel natin r. There, cancel ang pi. So, therefore, r over 2. And given yung discharge na 1.5 as well as yung slope. So, we can find the depth, no? Kasi yung diameter, I mean, kasi same sign lang, same symbol. We can find the D and R, of course. So, 1.5. So, balik tayo dito. Equals now to, yung area is pi r squared over 2 times 1, yung n to ha, n is 0.012 times yung r is r over 2, 2/3, at yung s is 0.007 to 4.5. Therefore, let's do the math. It turns out na same lang, no? Yung r to the power of 8 over 3 kasi r squared times r to the power of 2/3, no? Equals now to 1.5 times 2 times 0.012 times 2 na carry sa 2/3 all over pi times 1 times 0.007 raised to 1/2. I-times natin yung 3 over 8 para makancel. Ito, 3 over 8. So, therefore, the R is 0.564 of a meter. So, thinking that D is 2R, it will be 2 times 0.564 and G is 1.128 meter. So, this is the answer. Or the section that we are finding. The perfect, no? The most efficient. Or yung mass na sinasabi. Sa rectangular naman, this one. So, B equals 2D over yung D. Wherein A equals to 2D squared. Tapos yung R, no? Yung R natin is D over 2. Right? So, Q is AV or A times 1 over N R to 2/3 S to 1/2. So, 1.5 equals now to 2D squared times 1 over 0.012 times D over 2 raised to 2/3. Yung S is 0.007 1/2. So, therefore, D is raised to 8 over 3 and 1.5 times 0.012 times 2 raised to 2/3 over 2 times 0.007 raised to 1/2. So, 3 over 8, 3 over 8, cancel. So, our depth now is 0.515 of a meter. And our D is 2D. 2 times 0.515 or B is 1.03 meter. So, these are the answers. So, that would be for tonight. So, we are ending with the most efficient cross sections. So, this is the part 1 of the chapter 8. So the next part would be discussing about the alternate stages of flow and the critical depth of any section, the non-uniform flow or varied flow, as well as the hydraulic job. And it would be so exciting to discuss it with you. So thank you for listening. Hope you have understood um, my discussion, even though I have not good penmanship, but hoping that my penmanship doesn't affect your learning, no, when it comes to my video. And thank you for watching. Have a great day. Goodbye.